Hello everybody, so I'm Dr. Sergey Sarkisov, and I'm going to do today a summary or overview of the basic or fundamentals of trigonometry, okay? So let me write that, trigonometry, okay? Trigonometry. And notice that word tri there, kind of Latin for what? For three, right? And what that has to do with is basically three, whether it's vertices or angles or sides. We're talking about triangles, okay? And so when you think about, what about squares or quadrilaterals of any shape, right? Or pentagons, hexagons, heptagons, okay? Octagons, nonagons, decagons, okay? What do we do with that, okay? Those can be divided or dissected into triangles. So really, having a triangle down would be really having all the information for almost any shape, except for the circular, right? And that's the other type of shape where you have the kind of the pi, the curvature in there. So I always tell my students that having the straightness, the kind of the trigonometry with the angles and sides, with geometry basically, with that straight geometry, and then the curvature, right? The kind of the circular, that will give you kind of the overall shape of almost anything. And then, of course, there are some other details, hyperbolic, conic sections, etc. So watch this. Trigonometry, when we think of trigonometry, right, we typically are given these 6 trigonometric functions. The basic trigonometric functions are sine, I'm going to write them as words, cosine, tangent. So we hear these, and we're like, well, what are they? This is what we do. We work in trigonometry with these. These are actually ratios, defined as ratios of sides. We could have never invented these words. You could still do the same thing, right? You could do the ratios. For example, opposite over hypotenuse, as that sign is going to represent. But, in a right triangle, okay? But it really, initially, investment is what? That we have to spend time learning this, right? But what's the advantage? The advantage is you can speed things up later. When you know a skill or trait very well, it can help you do things a lot better with that strength or power when you know it. So anyway, sine, cosine, tangent. Then the reciprocals of reciprocal tangent is cotangent. Tangent. Then there's secant, okay, for 1 over cosine, and there's cosecant for 1 over sine. The representations, and this is of an angle typically. Okay, the input, the domain input would be an angle. So let's say, I want to say the angle is theta. Okay, so let's do this. Sine, now sin for sine, of theta. And then it's a function, so of. Now you can just put a sine theta without the parentheses, but I really want you to see that this is taking of something. You put the domain element, the input element, theta into sine, and you get an output, which is sine of the theta equals some value, right? Or some ratio. Cosine, cos, of theta, tangent, tan of theta, tan, cotangent, cot of theta, and then secant, sec of theta, and finally cosecant, actually csc of theta, okay? Otherwise, if I do cos, right, that would actually be the cosine. So now, what are these based on what I'm going to consider the main definitions of these trigonometric functions? Come from the right triangle geometry, okay? And we've done a little bit of geometry already, right? With what is an angle, what is a ray, making up those 2 rays, making up an angle, the vertex between them, right? We talked about parallel lines and the transversal and making those, corresponding angles, pairs of angles. We discussed even the proof of why the sum of the angles in a triangle is 180 degrees, right? And we discussed the proof of the Pythagorean theorem, okay? And so let's go back to that later if you have any questions, okay? But first, let's actually do the trigonometry. I want to give you the basic summary of kind of the gist of the trigonometry that you want to know for, let's say, most of the class structure. So here goes. Let me draw a right triangle. It's rather arbitrary. At least you need to have one of the angles being 90 degrees. So let's say I'm going to do this kind of horizontal line, maybe call it the base, and then this is the height, let's say, and this is my right triangle. Okay. So let's call this triangle A, B, C, where B is now here the base, right? And then A, opposite the angle A, is my height, let's say, and C the hypotenuse, okay? So like, again, I said base, B. Let's call this now angle theta. Let's represent that, the measure of that angle A, as theta, okay? And so this would be that, then what? That would be adjacent side to the angle. This would be this leg here of the right triangle. This is adjacent. Adjacent. This is opposite the angle. This is why we call it opposite side. And this is going to be the hypotenuse. Hypotenuse. Okay? And as you remember, hypotenuse is the longest side of a right triangle. Okay? And we've shown that this side, adjacent side squared, plus the opposite side squared is equal to the hypotenuse squared. Okay? And that's the Pythagorean theorem. Now, and also these angles theta and this is going to be 90 minus theta, 90 degrees minus theta, because these two angles have to add up to 90 degrees, because all angles in a triangle add up to 180. So the trio of the angles is supplementary, and the combination of these two, not the 90, is then going to be complementary. Now, what is my sine? What is my cosine? What is my tangent of these? Well, so let's do this. Sine will be the opposite of hypotenuse, and let's just say that's the definition. Okay, there's nothing more like how do you derive that, prove it? No, you don't prove anything. You have to memorize that basically. Okay? So this is what it comes from. So sine of theta is equal to, I'm going to say equivalent to, opposite over hypotenuse. I'm going to do it like that. And of course that would be A over C. In that case, cosine of theta, now we remember that's adjacent over hypotenuse. Tangent of theta would be opposite over adjacent. Okay? So that would be the A over the B in this case, opposite over adjacent. Okay? And then if you do cotangent, it's a flip of the tangent. But first we would just kind of define it as actually adjacent over, this is equivalent definition, over opposite. We would do secant as hypotenuse over the adjacent. Okay? And finally, the cosecant, you can guess what that would be. Cosecant of theta would be hypotenuse over the other possibility, would be hypotenuse over the opposite side. So of the combinations of hypotenuse, opposite, adjacent, if you actually do some number theory, what is it? You have possible combinations, permutations would be 3 times 2, which is 6. And so we have 1, 2, 3, 4, 5, 6. These are the only possible trigonometric functions for the ratio of 2 sides of a right triangle. You have 3 sides, right? And you choose, basically the 3 in the order does matter as well. Okay? So there's another way to think about that. Okay, now, so sine is this, cosine is that, tangent is that. We have to know all this now. Let me show you another thing. So let's look at this. It's kind of the right triangle trigonometry. Now let me go to a unit circle as well. Now let me transition this to a unit circle. So what we can do here is the unit circle. Let's try this marker here. The unit circle. And we'll look, of course, a lot more into this still, right? But look, unit circle, I want to combine this concept with what we're doing now, is it's a circle centered at 0, 0 with radius 1, okay? But what's important about the unit circle is, let's say if I have a circle, okay? And so, again, my radius is 1. Let's say this is 1. That's a 1. That's a negative 1 right there. That's a negative 1. And so this is a radius 1 circle, okay? I'm just going to sketch it out a little bit. So there's my circle, let's say radius 1, okay? And let's say I give you any angle. Let's say, so angles, remember, we go counterclockwise for positive angles, okay? So let's say I have, here's my theta. Okay? That's my theta angle. Okay? So now, and this is, let's say, my point, right? The coordinate x comma y, right? The x value and the y value. And so if we can break it down into the horizontal and the vertical components, right? We get this. Now this is radius 1, the unit circle, unit meaning radius is 1. Now what's interesting is let's actually look at this, what's cosine of, this means actually this is little x here, right, from here to there. And this is my little y height. Okay? So what is cosine, what is sine of theta? So let's try cosine of theta, and by looking at the definition there that I've given, it's going to be adjacent, which is, for this right triangle, there's a right triangle there, okay? We often in trigonometry break the things down into right triangles. It's going to be x, the adjacent, over the 1, the hypotenuse, right? So x over 1. And that's exactly x, right? So x is cosine theta. In unit circle, always cosine theta. Okay? And what is my y? What do you think it's going to be? Y. Well, watch this. Look, let's try sine of theta. And we get what? Opposite over hypotenuse, which is y over 1. And that's exactly my y, right? So it turns out that for a unit circle, my y will be actually the sine theta will be the y. So this is my sine theta. Interesting, right? Because now if I know a point, let's say I have a point square root of 2 over 2, square root of 2 over 2. Well, then I know whatever that angle is that gives me that point. I know cosine of that angle will be that root 2 over 2, and the sine of that angle will be root 2 over 2, whatever values I have for x and y, okay? Cosine is x, sine is y. And so we'll look into this more and more. And this helps us with negative angles or really big angles, right? Because in a right triangle, this is going to be between 0 and 90 degrees. Okay. So now, let me show you something very interesting. Let me show you something very important. We have this result for common angles, okay? And common angles we really discussed were, I call this the trigonometry table, but common angles that we consider in this class are the angles 0 degrees, 30 degrees, okay? We have the angles 45 degrees also, 45 degrees and 60 degrees and 90 degrees. These are the angles, especially these right here, are kind of are correlating with each other. This one is very important, and these are a little different. These are the quadrant angles, and they're going to be difficult to kind of look and get this information for what sine of these and cosine of trigonometric functions. What are the trigonometric functions of these based on the triangle? Because think about it, 0 degrees, what is that really geometrically, right? Kind of confusing. And then 90 degrees, what is that? We already have a 90 degrees. So that's going to be a little confusing, but I'll try to show you what the geometry of this right triangle can do for us. So let us look into the 30 and 60, okay? And watch this. When I think of 30 and 60, I think, well, what kind of right triangle has 30 degrees and 60 degrees? Actually, 30, 60, 90 triangle, right? So look at this. Let's do a 30, 60, 90. But before that, 30, 60, 90 is actually half of a triangle that's even easier. What's the most symmetric, what's the nicest triangle we can think of? It's the equilateral triangle, right? So the equilateral triangle, is what? It looks like this, with 60, 60, 60, because all angles have to be the same. So 60 degrees, right? And the other one 60 degrees. And then all the sides would be the same, okay? So let's say this is that, and so on. All the sides are the same, okay? And now look, let me divide this triangle into two little ones, but divide this with an angle bisector, okay? Where the thing that makes this angle the same on the left and the right, it divides the angle into two pieces. Actually, what's going to happen because of symmetry, this is also going to be the median, because the sides are going to be the same. So this side will equal to this side. And actually, these triangles, this little one here on the left side, this right one, they're congruent here. This is going to be the same angle as that one. If it's 180 for a straight angle, divide that into two. This is 90 degrees, and this is 90 degrees. Okay? These are both right triangles, and so this actually will be the angle bisector, the median, okay? The perpendicular bisector, and the altitude as well. So actually all of those Chevians that we discuss sometimes in geometry are relevant for the specific angle bisector or thing that divides this triangle into two pieces. Now, why I'm saying this is let's make it be easy on ourselves, and we say, okay, well, because the scaling, right, this is all about ratios. Why not call this side, and I can call it side S, but I'm just going to make this side length 1. Why not, right? Because if it was 2, the same ratios, because everything's just going to be doubled by size. Well, I'm going to call it 1. I don't have to. I can just call it S, and then we're going to divide the S's out. I'm going to keep it as 1 here, and then keep the 1 here. And then what about this? I divided this into 2 halves, basically, right? Equal 1, so 1 half and 1 half. And what I'm going to do is I'm going to specifically look at the 60. That's 30 degrees, right? And 30 degrees, because we divided that angle 60 degrees into 2 equal angles. So 30, 30. So, but I'm going to look into this 60, 30, 60, 30, 90 degree triangle. That's a 30, 60, 90. Okay? And let's just look into that triangle, because now if I tell you, okay, what is my sine of 30 degrees? That's a very common question I ask even in calculus classes when I begin teaching a calculus class. I will say, okay, well, who knows what sine of 30 degrees is? The first day of class. Typically, I will actually ask that maybe as the first question in a joking fashion, not to make students uncomfortable, but I want to see myself. What am I supposed to do? What am I working with? What class am I working with? Because a lot of times, I do remember, for instance, and this is actually a typical scenario where I ask, and comfortably 5 out of 60 students know that sometimes. 5 out of 60, that's less than 10%, right? And the answer to that, again, comfortably. So of course, if you think about, if I gave them some time to think about it, maybe more like 10 would know it. And then of course, when you do an integral of cosine and whatever, and then you don't have to know that, but how do you finalize that problem? And is this 5 or 6 radians or 30 degrees? Anyway, sine of 30 degrees, what we can do is, how do we derive this result? Well, what we have is, we have what? We have that this is, take the 30 right here. Now, what's opposite over hypotenuse for the 30? Well, 1/2 over 1. Okay, let's see. So we do 1/2 over 1. And that's exactly 1/2. We have derived that sine of 30 degrees. Not just guessed. We derived it's 1/2. Sine of 30 is 1/2. 1/2 over 1. Okay? And you may wonder, well, hold up. Now, Dr. Sergey Sarkisov, what's wrong is you gave us 1/2. You made this 1. Triangle's not always 1, 1, 1, right? Well, if this was 2, that would be a 1, and it would be 1 over 2. Okay? So, again, it could be s and this would be 1/2 s, right? And you still have the s's cancel. It's still going to be always a 1/2. This is an arbitrary right triangle, okay? Turns out. Because, well, no, not arbitrary, it's 30, 60, 90, but 30 arbitrary size. It's a 30, 60, 90 triangle, okay? Now, let's look at cosine. I think you can follow from here. Watch this cosine of 30 degrees. What is that? Well, that's going to be now adjacent over hypotenuse. Do I know my adjacent side? Let's use the Pythagorean theorem to find it. So let's call this h. Okay? I know it's going to be h over 1, right? But what is my h? Well, the h here will be, look, we have the Pythagorean theorem, 1/2 squared plus an h squared, right? The square plus that squared is equal to 1 squared, hypotenuse squared. And so we have 1/4 plus h squared is equal to 1. H squared is equal to 3/4. Take away 1/4 from both sides. Okay? And then what is h? Square root of 3 over the square root of 4, or root 3 over 2, right? So h is equal to root 3 over 2. And we'll take the positive of that, not plus or minus, because we're talking about sides of a right triangle, right? So square root of 3, let's put it here, over 2, and then over 1, so it's just square root of 3 over 2. That's where if you ever remember, you see this root 3 over 2, root 3 over 2, that's where it comes from. Okay? And so you can do the other ones. For example, let's just do one more. Tangent. Tangent of 30 degrees is equal to, now that's going to be what? That's going to be opposite over adjacent, right? So it's going to be 1/2 over h, which is going to be 1 over 2, and then over root 3 over 2. That's 1 over root 3, the halves cancel. 1 over root 3. And if you rationalize and make this simplify it, it's going to be root 3 over 3, okay? And that's my tangent of 30 degrees, for example. Now, you can do other angles. What about the other angle that we can really look into? We've done this one. And of course, you can do any trigonometric function. You can do the other ones, the cotangent, secant, and cosecant the same way. Let's try a 60-degree one. So that's the other angle that comes straight from this 30, 60, 90 triangle. Watch this. How about sine of 60 degrees? Okay? And what that gives you is, well, 60 degrees, the opposite is h, and the hypotenuse is 1 still, right? So now it's h over 1, and it's just like the cosine used to be, but now this is root 3 over 2. And let's just try cosine of 60 degrees. Okay? And what happens is we get adjacent over hypotenuse, 1/2 over 1, and that's equal to 1/2. Okay, so this is how you work with a 30, 60, 90 degree triangle to get those trigonometric functions of these two angles, okay? This is huge. This is a big result, and we know that, right? Now, what's the other triangle that can give me, how do I get a 45-degree angle anything, right? You do the following. What is a triangle that has a 45-degree angle in it and a 90-degree angle, the right triangle, right? It's the 45, 45, 90 triangle. Watch this. If I do, let's say it's not even to scale necessarily, but let's say this is 45 degrees and this is 90. Well, if you add these up, it's 135. 45 away from 180. This is also 45 degrees. These are equal angles in measure, right? Same angles. This is then going to be an isosceles triangle. We studied that. So let's say I said, well, let's call this side 1. Hypotenuse is 1. What's my side here? And they're the same side lengths, right? What is my s? Well, let's do Pythagorean theorem. And we will get s squared plus another s squared, right? This squared plus the squared is equal to 1 squared, or 1. And so we have 2s squareds is equal to 1, and then s squared is equal to 1/2. And then s is equal to, take the square root of everything, plus or minus, but we'll do the plus, right? We care about the side length and positive, right? So the square root of 1/2, which is equal to root 1 over root 2, which is s is equal to 1 over square root of 2 times root 2 to rationalize and simplify, and we get root 2 over, that's a root 2 is just a root square root of 4 over 2, right? And so that's my side. Just took a little, did a little Pythagorean theorem to prove what the side length is if this is a 1. It's a 45, 45, 90 triangle. Okay. So why do I need that? Because now I can find a lot of information, such as what are my sine, cosine, and tangent of these, and the other ones as well, the trigonometric functions of these angles, of this specifically 45-degree angle. So now we're going to do this one, 45 degree. And so we have, let's do sine of 45 degrees. And what is that? Let's see. And let's do cosine. I'm going to write that down as well. 45 degrees and tangent of 45 degrees. And let's just do add one other one. Let's say we have cosecant of 45 degrees. Because you can find any trigonometric functions from here. So look, sine of 45 degrees. Okay. It is going to be, again, opposite over hypotenuse. So take any angle of the 45, it doesn't matter. So let's do this one, at 45. Now, opposite over hypotenuse is s over 1. Okay, so s over 1, oh, that's exactly root 2 over 2. Okay, I'm done. And so cosine 45 degrees, very similarly, you can take any of the angles, but let's say that specifically take this 45. Adjacent over hypotenuse, I still have s over 1. They're equal, right? They're still sine and cosine 45 degrees. Root 2 over 2, root 2 over 2. Now tangent, you can do a trick of doing this sine over this cosine, right? Or you can just go ahead and say, well, opposite over adjacent, if you're using the same, well, it's s over, what is that? S over s? And that's exactly 1. And what is cosecant? So tangent 45 degrees is 1 actually, right? And actually tangent 45 degrees, it's going to be like the y over x, the opposite over adjacent, right here. Opposite over adjacent, and that's going to be the slope of that little line, of the line going through 0, 0, and having that angle theta. So tangent of theta will be the slope of the line, if you can extend this, for a unit circle, okay, idea, okay? So cosecant 45 degrees, let's do that one. It's what? Hypotenuse, look at that, over opposite. So hypotenuse would be 1, opposite would be s, and we have now 1 over root 2 over 2, or it would just be root 2 if you simplify it. And so that's how you do angles 45 degrees, 30 degrees, 60 degrees. Okay? And so we have trigonometric functions of all those angles now. And you may wonder, well, hold up, we didn't do secant of 60 degrees. Well, flip the cosine, right? Or you do not adjacent over hypotenuse, but hypotenuse over adjacent. You get 1 over half or 2. Okay? So you can do all of those 6 trigonometric functions for all these 3 angles now. Okay? All right, so let's continue here with some of the other 2 angles, okay? And what I'm going to do here is I'm going to transition to a unit circle. So what I can do is, let me make it a little more involved, a unit circle. We're going to start filling it in, actually in this diagram. So here's the unit circle, okay? And what I can do now is I can say, okay, well, look. Let's say this is 30 degrees. Okay. Let's say this is 30 degrees. Let's do this. So I'm going to erase this now. And what we know is cosine cosine is what? Cosine is the x value, sine is the y value. So let's say I do 30 degrees here. Okay. Guess what? What's the cosine of 30? Root 3 over 2. Root 3 over 2 it is. And then what is my y value? The sine, 1/2, right? Sine of 30, the first thing we found actually. Sine of 30 degrees is 1/2. Okay, what about 45 degrees? We've done that one, right? 45 degrees. And we know it's going to be what? Sine and cosine are both root 2 over 2. Okay? So this is going to be x is root 2 over 2 cosine, and then the sine or the y, 45 degrees, it's going to be root 2 over 2. And if I do 60 degrees, right? What is that? That's also going to be now cosine's 1/2. We've done that. And sine is root 3 over 2. You can see that we've done all of these here. And again, you may wonder, well, what about all the other 4 trigonometric functions of these? You can work with the x and the y in similar fashion, right? For example, if I tell you tangent, you just do the y over x, because you have the opposite over the adjacent. If I do cotangent, I say, look, I do the x over the y, okay? The adjacent over the opposite, cotangent, right? And so that's what you can do. You can play around with these numbers now to get any of the 6 trigonometric functions of those specific angles. But we've done the 3 angles, so what? We haven't done more than that, right? What about this angle, the 0 degrees, right? That's when we do not go anywhere from this positive x-axis location. So look, if I do 0 degrees, well, we know this point is 1, 0, right? So we can follow from here, or see from there, that what? That cosine of 0 degrees is equal to, what is it equal to? It's equal to this 1, okay? Should be equal to 1. And what is my sine of 30 degrees? That should be the y value there, which is 0. Okay? You may wonder, well, what about tangent of 0 degrees? I don't know what that is necessarily. Well, tangent of 0 degrees would be sine over cosine, but let's not do that necessarily. That's another identity we have to show. These just, it's visible for some, but for some other students it may be may take a few steps. But anyway, look at this. What's opposite over adjacent? Well, there's no opposite. It's 0, right? 0 over 1. So you would do 0 over 1, which is just 0. And then I'm asking you a question, well, what about cosecant, let's say, of 0 degrees? Well, that's actually 1 over the sine, or 1 over the, what? The opposite, the hypotenuse, which is basically 1. So everything in the radius is 1. Over the opposite, which is 0. What's dividing by 0, though, right? There's no opposite, in a sense. Length is 0. Dividing by 0 is going to be undefined, right? So undefined. And that's why you sometimes in the tables, you see that u there, okay? Undefined. Cosecant of 0. This is here dividing by 0. Now, another way to show you a few of these ideas is the following. Let's do for the 90-degree case. So I'm going to stick to this right triangle idea for a moment instead of going to the unit circle, okay? And then we'll check with the unit circle. So let's go ahead and do this. What if I ask you, oh, okay, well, give me sine of 90 degrees. And I'm telling you, don't use that unit circle. You probably see that point, what it would be and what the y value of that is. But look, sine of 90 degrees. Well, what I can do is, I can say, look, I have a triangle, and one of the angles is almost 90 degrees. It's almost 90, right? So, because, in a right triangle, you need all angles, besides, if one is 90, all the other ones will be less than 90, right? The sum is going to be 180. You need 3 angles. So what I'm going to do is I'm going to say, look, I have a 90-degree here. I do have that one, right? That's the right triangle. And then, how do I get a 90, another 90? You can't get exactly 90. It could be like a limit problem. But I can get, maybe like 89 or something like that. So let's say I exaggerate, and this is an angle that we're talking about, theta. Theta is going to 90 degrees, okay? Approaching, limit. It's more of a calculus kind of concept. But look, and this is then going to 0, right? So this is going to 0 degrees. Now, what is sine of 90? Well, this is hypotenuse. This is opposite, right? This is adjacent. Now, what is opposite over hypotenuse? Opposite over hypotenuse. Now you see how if it's exactly 90 degrees, this is just going to overlap. This angle, if this is also 90, what's going to happen is it's going to go up, 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 and it's going to, this is a 90 degree here, and so it's going to connect in a sense. Where they're going to be now, the opposite hypotenuse will be overlapping. It's going to be the same, so it's going to be really the same thing as, let's say, 1 over 1, or it's going to equal to 1. It's going to go to 1, okay? The ratio will be the same. And then what about cosine of 90 degrees? That may be even a little easier to see. And this is a little confusing. A lot of students struggle with this ideology of, or concept of how to use this right triangle, this concept of how the limiting, right, visually makes that sine 90 degrees is 1. And how about cosine of 90? What about that one? Well, think about that. That's going to 0. This side is adjacent going to 0. So it's going to be adjacent over hypotenuse. But hypotenuse is something, right? It's like the longest side. Adjacent is going to 0. So it's going to equal to 0 over whatever it is over hypotenuse. So it's 0. And then let's check. How do we check? Well, we look at the unit circle, and we see this point, right? In the unit circle, that point, the top one, is going to be, well, 0x and what? 1y. So again, 0 is a cosine, 1 is a sine. Is it the case? Yeah. Look, 1 is the sine of 90, 0 is a cosine of 90 degrees. Interesting, right? So it works out. And of course, it's probably easier for you to follow this, cosine sine, right? But I wanted to show you, sometimes you don't get to the unit circle until later in class, right? So we've done that, of course, already. So that's a little bit of a this and that here on the trigonometry side, okay? And so let's finalize this class today, okay, with getting all of these points and then being able to find trigonometric function of any angle, okay? Watch this. So we have 0, 30, 45, 60, 90 degrees. We did that. In fact, this one also did. We have done now, okay? And so look, now what if I go another angle? Well, probably the next one would be 120 degrees, okay, for you. You can probably see that. Because again, I'm seeing the symmetry here that look, this and that are, they're all both 30, right? 60 from 90, 30, 120 from 90, 30. And then this is just a point to this point. They're symmetric, right, about this y-axis. So what's going to happen, this is going to be a negative 1/2, right, left 1/2. Look at that, right? A beautiful result in a sense. And this is still going up the same height, root 3 over 2. So if I ask you, oh, what's cosine of 120 degrees? Negative 1/2. Okay, so you can see cosine is a negative 1/2, sine is a root 3 over 2 still. Sine of 120 is the same thing as sine of 60 degrees. And then, of course, you can follow along from here and say, well, what about 135 degrees? It's going to be 45 away from here, and this is 45 there. So you look at that one and you go negative root 2 over 2, and then positive root 2 over 2 for the height's the same, going up, right? This one would be, what about 30? This is 30. What about 30 shy of 180 degrees? That's 150 degrees, right? And that's going to be this point, the left, negative root 3 over 2, and comma 1/2, still 1/2, okay? So sine of 150 degrees is actually 1/2. What about, let's say, cotangent? Cotangent is going to be adjacent over opposite. Adjacent over opposite is x over y. X over y here would be negative root 3 over 2 over 1/2. And so we can see that from here, still interesting exercise here, what is cotangent of 150 degrees? Well, it's equal to negative root 3 over 2 over the 1/2. And now at 1/2 cancel out, you get a negative root 3 over 2, negative root 3, period, right? So this is that, negative root 3. And that's how you work with this unit circle. We can definitely see this is a negative 1, comma 0. And you can do the other one angles as well, in the same fashion. So let me just do that for us. This is going to be 210 degrees. And then this is going to be the same one but going down. So it's actually negative root 3 over 2, comma negative 1/2, right? Because this is quadrant 3, right? Quadrants 1, 2, 3, 4. And in quadrant 3, everything's negative. X is negative, y is negative. Let's do 225 degrees. Okay, and that's going to be negative root 2 over 2. And then negative root 2 over 2. Let's do this one. What's 30 short of 270? 240, right? And so you get a negative 1/2, right? Comma negative root 3 over 2. We have this one, which is, we can definitely see that point is a 0, comma negative 1. And that's a what? This is 180 degrees. This is 270 degrees there. And then we can finish up with, this is 300 degrees. We get this point to get to the right, so 1/2, negative root 3 over 2. We get this point, right? What's that point? 360 degrees minus 45, so 315 degrees. We get a positive root 2 over 2 and negative root 2 over 2. And finally, the only other angle that is let's say we call these coterminal angles, they're in the 0 to 360 range, and they're of the common angles. The reference angle, by the way, is always the angle between 0 and 90. Okay? So, for example, reference angle 315 would actually be that 45. And you work with that and you wonder, well, is sine positive or negative? If sine of 315, is it positive or negative of sine of 45? And actually, because it's going down instead of up, here it would be a negative, and negative root 2 over 2 for 315. Now this is 330 degrees then. This goes back to 360, so we don't have to do that. But 330 degrees, and that's going to be this one going down, so negative root 3 over 2, and then 1/2, and positive root 3 over 2. And then a negative down, right? Negative 1/2, the y is negative. And so that is the unit circle. I know it's very kind of densely written here, right? Very hard to see exactly what everything is, but hopefully you can still see and understand everything that we did today. And that's a summary of some of the trigonometry that you would want to know. And so again, I did mention that we would do an interesting angle, some kind of messy angle. So watch this. Let's say I finalize today's lesson with, we did common angles, with a question such as, okay, well, what is my secant, let's do a challenging problem, of negative, let's try something like this, negative 750 degrees. Well, it's different. I don't see anywhere negative 750 degrees. And what is negative? Negative is going clockwise, right? So what you do is, one way, especially this is not that big of an angle, it's not like 70,500 anything, okay, is you can look at this and say, well, let me see where that angle is, right? Where's that terminal side for that angle? Well, I'm going to go 90 degrees. And then I'm going to go another 90, so 180, 270, 360. Okay? You could see it's 360. Another 360 would be 720, negative 720. And then what's 720 and 750? How much more do I go clockwise? 30 degrees, right? So here I am. That 30 degrees extra, that's 30 degrees. This is actually my negative. That angle is right here, is my negative 750 degrees. Okay? And so that 30 degree is a reference angle. It's always with respect to the x-axis. And so what we have is, we know that point right there. Look, it's the same thing as 330. It's that same location. It's that point, root 3 over 2, common negative 1/2, right? And we have secant is going to be, remember, what is that? That's going to be hypotenuse over adjacent. Hypotenuse over adjacent. Hypotenuse is, again, for a unit circle, it's a 1, right? And then that's adjacent is the x value, right? So adjacent, x value for an angle. And what's 1 over x? Well, x is root 3 over 2, positive. So we have 1 over root 3 over 2, which is 2 over root 3. And if we simplify that further, it's going to be 2 root 3 over 3. And that would be our secant of negative 750 degrees. And that's a rather arbitrary angle, right? Still has commonality in the sense that the reference angle, I chose it so that I have a reference angle that's 30 degrees. In other words, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Those are the only angles we have done thus far. This is a very big, hopefully, an important topic in class that you could kind of use to overview some of the basics of and fundamentals of trigonometry. Thank you so much. Everyone have a great day.